I create emerging technologies for emerging markets. And I got my start in this field by designing this wheelchair you see here called the Leverage Freedom Chair. The LFC is a lever-powered off-road all-terrain wheelchair that was primarily designed for rural areas of developing countries. The key innovation behind the LFC is that to go fast, the user just grabs the levers down near the pivots and can push through a big angle every stroke. And as the going gets tougher, they can slide their hands up the levers to produce more torque and go off-road. This enables the LFC to travel about 80% faster on the street than a normal wheelchair, go about 40% more efficiently, and produce about 50% more torque at the wheel. So effectively giving the user a much higher and much lower gear than a normal wheelchair and able to go on any type of terrain. What I find exciting about doing this type of work is that when you go to emerging markets, the constraints you face push you to create innovative new solutions. So in the case of the LFC, we could look at wheelchairs in the US that cost $6,000 and go off-road great, but we had to produce a product that cost only $200 and gave those type of capabilities. And when you create high-performance, low-cost technologies, not only can you make an impact in the developing world, but you can disrupt markets in countries like the US and Europe. And we're doing that right now with the LFC. And this idea of constraint-driven innovation is one that I'm using in my research group for all of our projects related to low-cost, high-performance prosthetic legs, low-pressure, low-power drip irrigation equipment that's affordable for small-scale off-grid farmers, water purification technologies that are both good for village scale and commercial applications, and high-power, low-cost farm equipment. And in all of these projects, we have to meet or exceed the level of performance of technologies we could get in this country, but at 1/10 to 1/100th of the price, right? And if you can do that, you can make an impact in the developing world and disrupt the markets globally. Another exciting part of this work is being a global engineer and training global engineers. And in all of my projects, what we try to do is bring together all of the stakeholders that represent each link in the chain of the inception of a new technology, in that idea, all the way out to its implementation in the real world. And by doing so, those stakeholders can exert their constraints and requirements on the design and really guide it to fruition. So in the case of our irrigation project, here's a picture from India where we had a farmer talking with an irrigation engineer, talking with an MIT geek, and when you bring that knowledge together, I think you can produce something better than each of these groups could have done alone. And the other exciting thing about training students is that I want to train engineers that can go anywhere in the world and understand both the technical and socioeconomic factors behind a problem to create high-performance, low-cost technologies that are appropriate for the developing world and disrupt markets worldwide. My name is Amos Winter, and I'm a professor of mechanical engineering here at MIT. Thanks.